Welcome to this video tutorial. Today we are going to be demystifying stoichiometry, and this is the second of this series. The first video on this series, which was demystifying calculations in chemistry using chemical formulas, chemical equations, how you can get better at chemistry. So you can go look out for that video. Is on this YouTube channel. So this video is like a continuation, and I'm going to be diving properly into the mole concept. In the course of this video, we're going to be learning how to solve questions on the number of moles and how to relate them with the different expressions you can get. For instance, as shown on the board, we have different formulas for number of moles. We're going to be examining all these different formulas, solving questions, and demystifying the concept. The good thing you can do for yourself is to watch this video right away. Just take your writing materials, your book, your pen, and even your earpiece. If you need a earpiece or earbud to be able to hear me clearly. So, because I'm going to be diving straight into this video. Don't forget that this is a series, so you must follow through from the previous video to this video and to the subsequent videos that are going to be coming after this. So, let's dive straight into this video. If you are new here, my name is the phenomenal Dr. Jeremiah, as I'm popularly called, and I'm the CEO and co-founder of Unusual Science Tutorial, the online tutorial for JAMB, Poshutemi, WAEC, and what have you, that helps science students ace their exams effortlessly and do very well in science. So this is just one of our free videos that was made available to the public, so you can do well to also be part of the main tutorial and learn a whole lot of stuff. So if you are ready for value today, let me see in the comment section and type I'm ready for value. At this particular point you are watching it, just type in the comment section I'm ready for value, because today is going to be fireful. It's going to be one of those videos you are never going to forget in your lifetime, because it's going to help you dissolve every question on the mole concept and this part of stoichiometry. That being said, let's just move into the video right away. The first thing you must take note of are the different formulas on the mole concept. So we're going to be examining the different formulas. So we have here, these are the different formulas for the mole concept. So the first one is, make sure you are jotting this thing down, because we're going to be using them throughout the course of this video. Number of moles equals to mass over molar mass. Now, mass is in grams, while number of moles is in gram per mole. Why is it in gram per mole? Because N is number of moles and N is in moles. So if you want to make molar mass solve the formula, so you're going to be doing molar mass, let's represent as mm, equal to, if you multiply now, if you cross multiply, if you make this one over 1 and cross multiply, you're going to get number of moles times molar mass equals to mass. So if you make molar mass subject to formula, you're going to get mass over number of moles. So mass is in grams, the number of moles is in moles. So you have gram per mole, and according to indices in mathematics, we can simply just write it out as gram per mole. So it's going to take -1. So that's how we get the unit of that guy. Now, the second formula you should take note of, this guy, is concentration times volume in dm cube. Please take note. Concentration times volume in dm cube, and concentration is in, you can have concentration in both gram per dm cube and mole per dm cube. So we can have concentration in these two units, but the concentration we have here now is in mole per dm cube. Is in mole per dm cube. Please take note. Is in mole per dm cube. During the course of this stoichiometry video, we are going to be examining that gram per dm cube and mole per dm cube and what they actually mean. But for now, the concentration in this formula is in mole per dm cube. Now, volume is in dm cube. But in your exam, there's something that they do in O-level exams, that the examiners do to trick students. They can make this in cm cube and not dm cube. Now, as a smart student, how do you convert cm cube to dm cube? Because your formula must be in dm cube. Why? We have mole per dm cube and everything must correspond. Let me teach you a secret in science. It's going to be helpful for your physics and your chemistry, and I think to an extent mathematics. Your units must correspond. You have mole per dm cube. So So it means that if there's anything like that involves this dm cube here, it means it must also be in dm cube. If we're having cm cube here now, then there's an issue. Why? Because here we have dm cube and not cm cube. We have volume. This concentration formula is made up of volume, moles divided by volume. So you see, if we now have mole, if for instance we had mole per cm cube now, and we have cm cube here, no issue, because cm cube and cm cube are aligning. But now we have mole per dm cube. I told you guys this is the unit for this concentration. Then the volume is what? If you now go and write it in cm cube, you are going to have an issue in the exam hall, because there's going to be an answer to it in the options, and it'll be like, I blasted the question, I killed the question, but you forgot to change your cm cube to dm cube. Now, how do you change cm cube to dm cube? So if you have volume, let me use this one. So if you have volume as dm cube, volume in dm cube, I want to change it to cm cube, all you just have to do is to multiply by 1000. But if you have it in cm cube, please jot down this thing. If you have it in cm cube and you want to convert to dm cube, what do? Just divide rather, not multiply now, because we multiply it when we're converting to cm cube. So this one will give you dm cube. Will give you the volume in dm cube. Why this one gives you the volume in cm cube? Remember this guy, from dm cube to cm cube. Then this one now, from cm cube to dm cube, be divided by 1000. Very simple. So in case the examiner tends to be tricky and they give you in cm cube and not dm cube, you already know what to do. Once it's in cm cube, divide by 1000 to give you dm cube. That's what we need for our solution here now. Now, the next one, number of moles equals to volume occupied divided by 22.4 dm cube. Volume occupied in dm cube and this guy in dm cube. Now, let me tell you something. If they give you volume in cm cube and you just have to convert to dm cube, you understand? Divide by 1000, because they usually give you the cm cube, to be honest. So you have to divide by 1000 so you can be in dm cube. Now, this 22.4 dm cube, in case they ask you a word question, what is this 22.4 dm cube? It is the molar volume of a gas. Is a constant. Molar volume. Please take note of these things. Molar volume. This molar volume, according to chemistry, is the volume that 1 mole of a gas occupies as STP. STP, standard temperature and pressure. So at standard temperature and pressure, and according to IUPAC, the standard temperature and pressure is 273.15 Kelvin. Then we have 1 bar. That's the pressure at STP. So that's what we mean by standard. You're going to see it, especially when you get to gas laws. So standard temperature and pressure. So this is the volume that 1 mole of a gas occupies at standard temperature and pressure, and is equal to 22.4 dm. So in case they ask you a word question and say that the molar volume of a gas is numerically equal to 22.4 dm cube. Now that's for that. So the formula is number of moles equals to volume occupied divided by molar volume. Then the next one is N equals to PV over RT. If you are conversant with the gas laws, you should know that this formula is related to related to something in the gas laws. It's called the ideal gas equation. The ideal gas equation. And the ideal gas equation states that PV equals to nRT. PV equals to nRT, the ideal gas equation. Now, this ideal gas equation, what is it telling us about? It's telling us that P is pressure, volume, V is volume, N is number of moles, R is the constant, the gas constant, then T is temperature. So please take note of this stuff. Now, I think you should take note of R. So the value of R is a constant. So R is usually in O-level chemistry, we usually use 0.082. So we can actually have 2 units for the ideal gas constant. So it can either be atmosphere dm cube. If it's in atmosphere and dm cube, then we're having 0.082. But if it's in joules, or they may represent it, they may not represent it as joules, they may represent it as Pascal meter cube, which gives you joules. I'm going to tell you how it gives you joules. So if they present it as Pascal meter cube, especially for those that are doing probably GC or under level or advanced, you may be giving unit like 8.314. But usually in O-level chemistry, we basically just use this one. And they won't give you in the question. And when you just like the question is having atmospheres, dm cube, you know that you're going to be using 0.082. I want to just show you this second one in case you are seeing joules. When I be like, how is R equals to 8.314? It's still correct. That's still correct. It's just that pressure will be in Pascal and volume will be in meter cube. Remember that R equals to PV over NT. From this formula, PV equals nRT. If we make R solve the formula, we're going to get R equals to PV over NT. So this formula is just telling us that pressure times volume divided by the unit of volume is dm cube. That's why there's minus 3. But these other guys, the reason why they're having minus 1 is because they are under. According to this, if you bring something up, you're going to take it minus 1. So they now have my mole minus 1, K minus 1, you understand? So that's how we got the units, the different units. So why is it this guy, why are they equivalent? They're equivalent because pressure times volume gives you work. Now, I don't know if I should just say this, although it looks like physics. It's physics actually. Work equals to power. Work equals to pressure times volume. We use it to calculate something in physics. Once you get to work done by gas, you start seeing things like work done equals to pressure times volume. You take note of it. I think there's a word question they ask in physics. This is not physics actually. I'm not going to say this, but there's a word question they usually ask in physics. They'll say, if pressure is this and volume is this, find work done. And many students don't know that work done equals to pressure times volume. I'll be like, where did JAMB see this kind of question? Where did they see this kind of question? It's actually, there's something like work done equals to pressure times volume for a gas. And this is what was applied here that made us have joules. Because if we replace this stuff, which is pressure times volume, we're replacing it with joules. Although this is the one we actually replaced Pascal and meter cube. You know that pressure can be in several units. You can have atmospheres, you can have bar, use bar here, you can have Pascal, you can have millimeter mercury and all that, meter of mercury and all that. Then volume can be in dm cube, can be in cm cube, can be in meter cube. As long as there's a cube. What is volume? Volume equals to length times length, which is meter cube. Remember, volume is what is it called? If you have length now, length is, or should you say length times length? If you still say length times breadth times height, I know this one many people know. Length times breadth times height. It's still length times length. Why? Because breadth is measured in meters, height is measured in meters. So it still gives you meter cube. So that's why you can use meter cube. That's why you can have cm cube, dm cube, another equivalent unit. It's just conversion. That is the difference between dm cube and meter cube. Also, atmosphere and Pascal, they're just conversions. And it's not relevant for this video because this is not gas laws. But if it's gas laws now, we're doing gas laws, I'll show you the different conversion from atmosphere to Pascal and all that. So you can just learn those stuff. What I'm trying to show in essence is that these two are actually equivalent depending on the unit. So please take notes. Although I don't know if chemistry is going to get to that extent. Although for basic O-level questions, you're going to be given as 0.082 in atmosphere and dm cube. You rarely see this one. This is just for probably advanced chemistry and all that. Now, that is for the the fourth formula for number of moles. N equals to PV over RT. Then N equals to number of particles divided by Avogadro's number. Now, what is the Avogadro's number? I think you should know it. You can type it in the comment section. Let me see. Before I write it out. Before you see it. Okay. So I think we should have written it out in the comment section. Now, the Avogadro's number is 6.022 times 10 raised to power 23. So this is the Avogadro's number. So we have number of particles divided by Avogadro's number. So sometimes they can ask you, look for number of particles. What do? Just cross multiply. Will now be number of moles times Avogadro's number, and you're good to go. To cross multiply just makes 1/1. Just do it like this. So you have number of particles standing alone, number of moles times Avogadro's number, which is 6.02 times 10 raised to power 23. With these 5 we have looked at, these are the different like formulas for number of moles. So I want to show you something. There's a reason why this is on the board. We have molar mass here, and usually an issue. For instance, the other questions now, we have a constant, Avogadro's number. This one now we have a constant. They'll give you every other stuff. They say look for number, we'll give you every other stuff. And you know your constant, 0.082 for O-level chemistry, normally. Then, volume occupied divided by 22.4. This is a constant. This one now, they're going to give you the concentration and the volume in the question. Once you want to use this one. Then, mass over molar mass. Molar mass now. How do you look for molar mass? Before I get here, how do you look for molar mass? Before I get here, take note of something. Take note of something that you cannot use all the formulas at once. You can never use all the formulas at once. Why are we having 5 different formulas? They can say look for molar mass, look for number of moles when they gave you mass. Look for number of moles when they gave you number of particles. It depends on what you are giving in the question. Once you just see mass, and you can look for molar mass by yourself. So from there, you know that this is the formula you're using. Once you just see pressure, straight up, N equals to PV over RT. Once you just see volume occupied, and they say look for volume occupied by the gas, just straight up, you are using this one. Then this one, let me, thank God I remember. Very important, because some people will not make a mistake between 2 of them. There are 2 different stuff. This one is for solutions. Aqueous solutions. Aqueous solution, that's substances that are dissolved. Why this formula is for gases? Hey, that's why I told you molar volume of a gas. So this one is for gas, this one is for solutions. So that's the difference. So they can say look for the volume in dm cube occupied by an aqueous solution of HCl by using this one. They say look for volume of gas occupied by a gas at molar volume. Look for number of moles. This is the formula. So you know the difference between 2 of them and the 2 volumes here. Back to our molar mass. Let's quickly look at what molar mass means. But let me erase this stuff. Alright, so let's quickly go back to molar mass. Now, before I go to molar mass, there's something called relative atomic mass. Relative atomic mass is the mass of one atom. So if we have HCl now, H has its own relative atomic mass. Chlorine has its own relative atomic mass. Remember when I was teaching you guys formulas? Formulas combination of 2 atoms or multiple atoms. For example, you have 3 atoms here. So these individual atoms all have their relative atomic mass that will not give us the molar mass. So you should actually know the molar mass of the first 20 elements, to be precise. And although it's actually easy to learn, how do you know it? Usually double the relative atomic mass of the first 20 elements, usually double the atomic number. Helium, its atomic number is 2, then its relative atomic mass will be 4. They are usually double the atomic number. But there are some exceptions, and we should take note of them. For instance, you should take note of lithium. Lithium has atomic number of 3. Let's just write 3. That's atomic number of 3, but its relative atomic mass is 7. It's not exactly double. So 3 times 3 is 6. It's supposed to be 6, but it's 7. Then we have beryllium, which is 4. The atomic number is 4, the 4th element. Then it is not 8, but 9. Now, next one we have is fluorine. Fluorine is the 9th element of the periodic table. But instead of having 9 times 2, 18, it now has 19. So you can see that these guys, they have +1. Lithium, beryllium, fluorine. Then we have what we call sodium. Sodium is the 11th element of the periodic table. Instead of having 22, it has 23. Are you seeing a pattern? Now, this is actually very easy to master. Although your exams will usually give you, but I've noticed something in the current exam that they try to omit it because they know you should master these things. They omit some of the simple ones, but if they start including elements that are maybe the atomic number is 50 something, 80 something, they will give you in the question. You don't stress yourself. But the first 20 elements, normally you should know this as a science student. What have you been learning throughout your secondary school? Okay, so sodium is 23. Then we have aluminium. Aluminium, which is 13. Instead of having 26, it has 27. Now we are not done yet. We are not done yet. We also have what we call phosphorus. 15. Instead of having 30, it has 31. See that all of them are plus 1. All the ones I've listed there. Then after phosphorus, we have chlorine. Instead of having 17 times 2, those 34. But this guy now, it does not have plus 1. It has 35.5. It's not even plus 1. Then after phosphorus, chlorine, is it chlorine? Formula for chlorine is Cl, not C. Sorry, I say formula. The symbol Cl. Then after phosphorus, chlorine, we have two controversial ones: argon, which is 18, then potassium, which is 19. I want to include calcium because of something. I want you to learn something, which is 20. Now, argon is not 18 times 2. 18 times 2 is 36. But argon is having 18 times 2 plus 2, having 40. Now, this guy is not having 19 times 2. He's having 38. But its atomic number is supposed to be, normally the trend is that as they increase, the relative atomic number also increases. Relative atomic mass increases. But that does not happen here. It's reduced. We have 39. It added plus 1. This guy added plus 2. It added plus 1. Then calcium obeys the rule. I said I'm not supposed to add it, but I don't want to add it. So calcium is 40. What does it tell you? If you want to learn it without wasting stressing yourself, you also know that once you know that calcium is 40, the next one is 39, 40. 40, 39, 40. Hope you get 40, 39, 40. And you have mastered argon, potassium, and calcium. Hope you get. So 40, 39, 40. Then these guys now, all of them are addition of 1 except chlorine, that is 35.5. Now for atomic numbers between 10 to 20, with the odd ones between 10 to 20 elements, the odd elements between 10 to 20, for instance, 11 is odd number, 13 is odd number. Know that even numbers have 2 and stuff like that. They have multiples of 2. So all of them, they don't follow the times 2, the double method. But the even ones follow it, except argon. Except argon is the only odd one. Is the only even number. No, its atomic number is 18. That is not having 18 times 2, but it's not having 40. For the ones that are between 10 and 20, then these three, just master them. Just master them. And the only exceptions for the first elements between 0, then between 0 and 10. Let's just use 0 and 10. So there are the only three that are exception, and it's easy to master them, and it's plus 1, just like these other guys that is plus 1, except these two. It's just these two that are not plus 1. Just these two are not plus 1. I'm supposed to use this one, but just these two that are not plus 1. So the other ones, yeah, they're all like plus 1. You get. So chlorine 35.5, instead of 35, it's now 35.5. Then this one, instead of being 36, like every other even element that are between 10 and 20, it is now having 36 plus 4, which gives you 40. So 18 is 40. So we have 40, 39, 40 from 18, 19, 20th element. Hope you get. So I wanted to just show you something. Then there's something you also master. There are some important there's some important large elements that you should learn. They're going to be shown on your screen so that you can master these things. I want you to master these elements, their atomic number and the masses, if possible. Can master it. I don't know. Maybe for instance, for post-UTME, they may omit it. I've seen a post-UTME exam, they omit it. But JAMB will surely put it. But post-UTME may omit them. So these are the important atomic numbers in your O-level chemistry. atomic number and their masses. So copper, zinc, silver, gold, mercury. So they are very, very important for your O-level chemistry. All right, so just master those guys. Now, let's quickly go back to our question. HCl. So what's the molar mass for HCl? Like I've said, we are going to just be adding the different relative atomic numbers that make up this element. For instance, now, HCl, H is is 1. Then from this, I just discovered I made a mistake in the course of this video. Hydrogen is not 2, but 1. Just remembered. Now, hydrogen, the atomic number is both 1 and the relative mass is still 1 for hydrogen. But for helium, you have 2 and 4. 2 and 4. So it's still 1 for hydrogen. Please take notes. That was a mistake. That was trying to show the double. I just remember that I said 1, I mean 2. But please take note of something. If you have H2, the relative molecular mass, I think this is where I made the error, now becomes 2. 1 plus 1 equal 2 relative molecular mass. We're going to get to the difference between relative molecular mass and relative atomic mass. And so if they say look for the molar mass of H2 or the relative molecular mass, it becomes 1 plus 1, which gives you, because this molecule means H plus H. I was explaining in the previous video, which gives you 2. Hope you get. So, but for a single atom of hydrogen, its atomic number is 1. And its atomic number is 1, then its relative atomic mass is also 1. Please take note. So it means that here we have 1. So 1 plus, I stated this previously that chlorine is 35.5. So it means that the molar mass of HCl is 35.5. Now, for H2SO4, same thing applies. Now, you see what I'm trying to say comes into play. Here now, for H2SO4, we're going to be having 2 times 1, because we have 2 atoms of hydrogen plus sulfur. Now, what is the atomic number for sulfur? Sulfur is 16. 16 times 2, 32. These are things if you just know and have your fingertip. That's why I can see all these things often. I don't have to now start, what was this? I start racking my brain. I already know automatically that this guy is 16 times 2, which gives you 32. It means that sulfur is 32. You know, they didn't give me the option in the exam. I know that it's 32. Then oxygen is 4 times. Sure, they'll actually give you the relative atomic mass, but not give you the you want to know that, okay, 4 times oxygen, relative atomic mass of oxygen. And since oxygen is 8, these are elements are represented, atomic number under, then their relative atomic mass on top. So 16, 8 times 2, 16. So we have 4 times 16. Please never forget, don't forget that you should not use the atomic number, but the relative atomic mass. So instead of now using 16 now, because maybe in the area, oh, sulfur is 16. Please don't forget, calm down. The relative atomic mass is 32. So from there now, if you sum everything up, you're going to be getting what? You're going to be getting 2 times 1, 2, 32 plus 4 times 16 should give you 64. From there now, if you add up everything using your calculator, 2 plus 32 should give you 34. 34 plus 64 should give you 98. It means that our molar mass is 98. And remember the unit for molar mass? Gram per mole. So for question 2 now, the molar mass is 98 gram per mole. Now let's go to number 3, glucose. What is glucose? You have to first write it out. According to your biology, for biology students, this is the formula for glucose, C6H12O6. Now, what are we doing? What is the atomic mass of carbon? Relative atomic mass of carbon. Carbon is in 6, then it's 12. Remember all those guys are double. They are just take the exception I gave you for elements between 0 and 10. So this guy is 6 times 2, 12. So we have 12 times 6 plus, what is that for hydrogen? 1 times 12. Relative atomic mass of hydrogen is 1. Then we now have oxygen 6 times, what is the atomic number for oxygen again? 8 times 16. So from there now, 12 times 6, 72. 1 times 12, 12. 6 times 16 should give you 96. I'm not mistaken. Yes, 96. You should know how to multiply all these things faster. As a science student, this artist should just practice. How can I get these things easier? I don't have to press calculator for everything. For instance, now the 3 I've solved, I don't press calculator because they are basic stuff. If I get to PB304 now or something, because they have large numbers, I'm still now try calculator. Hope you get. So now, if you add everything here up now, you have 72 plus 12 plus 96. I already know that there's going to be 0 at the back. Because 6 plus 2 gives you 10. So from there now, if I add everything up, I already know that this is going to have 0 at the back. 0. Then 9 plus 1 plus 7. 9 plus 1 is 10. 10 plus 1 is 17. Then 17 plus the one I carried. So now gives me 180. So 180 gram per mole. Just know how to solve things faster actually. It just saves you time in the hall. So 180 gram per mole is now the molar mass for glucose in that question. So let's look at number 4, number 5. I should just give you, let me give you number 5, number 4 asks assignment. Do number 4 and also number 5. I want to do copper and lead for a reason. Now, remember I said, okay, take number 4 as an assignment. Then copper, CuSO4. So what are we going to be doing now? We have copper. So let's rewrite it out. CuSO4. So we have copper, 1 atom of copper. And I said something that you should master. Copper is part of the element I say you should master. Because it's not, they're going to be giving you. So copper is 29. Then its relative atomic mass is 63.5. So you should just master them. So from there now, I have 63.5 plus sulfur is what? 32. Oxygen is 4 times 16. I've done it severally here. So we have 63.5 plus 32 plus 64. I think I have to punch the calculator in this scenario now. Let me get the exact answer. Although I can still work it out, but I don't want to trust. I don't want to give a wrong answer in the video. 64. That is 159.5. So the relative atomic, the molar mass rather of CuSO4 is 159.5. Now, I can tell you something. Let me just say this, and this is how I actually wanted to do 5 and 6. You can actually just do 64 and remove that point. It's not going to affect your answer. If you look at the options and see that the options are not close, you're not having points, something as a difference. 63.5 and 64 are actually very close. If I calculate something, I do something like maybe 159 divided by 5. Let's try it out, and let's try 160 divided by 5. I'm going to get similar answers. The difference in the answer will not be, it will just be something point. 159.5 divided by 5. Actually, one thing about UST, let me just say something about UST, is I will teach you something like to make things easier for people. That's why I always say students should be in UST. If you try to be in UST by all means, this thing now, some of you just, let me learn, 63.5 is somewhat difficult. But you see now, from what I'm going to do now, you see that it's going to become easier. You get, so this is how we make things easier for our students. So you can grasp, because you have a lot to learn. You have to compare the information and make sure you learn the important thing. And you are remembering them also. But you have to remember them in the exam hall. So now, 159.5 divided by 5 will give us, what's wrong with this thing? Okay, 31.9. So 31.9 for this one. Now let's see this other one. 160 divided by 5 will give us 32. The difference is just 0.1. If I add 0.1 here, I'm going to get 32. You can never see an option that has 31.9 and 32. Never. Because they expect you as a smart student to make this thing 64. You now start stressing yourself and now start pressing calculator. Or if you want to now add everything here now, you just be having issue. For instance, now if I add 64 Yeah, if I add 64 and 32, 64. I don't have to stress myself. I know that 4 plus 2 is 6, plus 4 is 10. 6 plus 4 is 10, yeah. So 0 carry 1. 3 plus sorry, not 3, 6. 6 plus 3, 9. 9 plus 6, 15. 15 plus 1, I'm going to get my 16. So it means that I'm going to get approximately 160 here. Don't worry, something can just work around. I want to just show you simple ways of solving questions. So 160, 159.5, almost similar stuff, and you get your answer. It's not going to affect your calculation at all. Now, PB304. PB304. What are you doing here now? You have lead and oxygen. So you must first know that lead is 82 and 207. I told you guys to master it. So that leads us to our solution now. So what are we doing? 207, because we have PB304. So 207 times 3 plus, what is the atomic mass of oxygen? 16 times 4. So from there now, you can punch it in a calculator. These are kind of figures that you don't just risk it. So 16 times 4, we're going to now get 685 as our molar mass for PB304. So this is the molar mass, 685 gram per mole. So we're able to get the molar mass for this question. So just solve number 4 yourself, and you're going to see that it's very, very easy. It's time for business. We're going to be calculating the number of moles for different scenarios. So the first question should be shown on your screen. All the questions actually. We're going to calculate the number of moles in these 7 different questions. So the first one is 5.3 grams of Na2CO3, 4.25 times 10 to the power 21 atoms of copper. You can just write out the question as before we proceed. 200 cm cube of 0.025 mole per dm cube HCl solution, 16 dm cube of hydrogen gas at STP, 250 cm cube of an aldehyde gas exerting a pressure of 72 mm mercury at 37 degrees Celsius, 32 gram of oxygen atom, then 32 gram of oxygen molecule. Now, let's quickly start with the first question there. So it says that 5.3 grams of Na2CO3. So now what do you do in this question? The first thing is to, what formula are we going to be using? I still have the formulas here so we can relate them. So the first formula, you say mass. I told you guys when you just see mass, know that I'm using number 1. So the formula is going to be N equals to mass over molar mass. So molar mass is usually represented with capital letter M. Capital letter M. Some people usually add M to it, but I think capital letter M is enough. While small letter M is represented with mass is represented with small letter M. So from there now, we have mass over molar mass. So the mass of the compound is 53, 5.3 rather. But the molar mass now, we have to look for the molar mass by ourselves. So sodium is what? I told you guys that sodium is 1123. Sodium. So it means that sodium is 23, and I've been doing carbon and oxygen ever since. So carbon is 612, then oxygen is 816. So you can actually master all these things. Now sodium is 23. 23 times 2 plus carbon is 12 plus oxygen is 3 times 16. I hope you are jotting these things down. From there now, you have 5.3 divided by 46 plus 12 plus 48. And that should give you something close to, wait first, okay, that should be 106. 106. You can punch it on your calculator and see if it correlates. So 5.3 divided by 106 is going to give you 5.3 divided by 106. That's going to give me 0.05. So our answer here is 0.05 mole. So for the first question now, I've gotten the number of moles for 5.3 gram of Na2CO3 to be equals to 0.05 moles. So the next question is 4.25 times 10 raised to the power 23 atoms of copper. 4.25 times 10 raised to the power 23 atoms of copper. Now, what are we going to be solving? As you just immediately saw atoms, you know, we're talking about Avogadro's number. Now, particles can represent three things. It can represent atoms, ions, or molecules. So you can have number of atoms, number of ions, number of molecules. So now we have number of atoms. They gave you number of atoms. I say look for the number of moles. What are you going to do is this formula. So what we're going to do straight up, n equals to 4.25 is even one of the simplest actually that you can get, times 6.02 times 10 raised to the power 23. Remember our Avogadro's number. So you must master these things. This one cancels this one. Then don't see, be very smart. Don't go and be doing times 10 raised to the power 23 on your calculator. If you're writing CBT exam, cancel it out immediately. So you are left with 4.25 divided by 6.02, which gives you 0.705. 0.705. So your number of moles is 0.705. Now let me show you something. Imagine this thing they wrote 42.5. 42.5 times 10 raised to the power 23. So I said you should just cancel all these 10 times 10 raised to the power 23. Yes. So what do you do now? You cancel it out and you're left with 42.5 divided by 6.02. And you get your answer. You don't need to stress yourself at all. So make sure you're cancelling out this one so you can just solve the other stuff. Hope you get. Now the next question quickly. It says 200 cm cube of 0.025 mole per dm cube, and we're talking about HCl solution. I might tell you guys that if you look at that formula I gave you now, there's one that regulates solution automatically. I'm using this formula solution. I tell you guys, this guy is for solution, this one is for gases. Basically, this one is also for gases too. You know, the ideal gas equation is for gases. Then this one can relate almost everything. Then this one also is for particles. Can basically relate all of them also. So these two can relate all of them. But this one is specifically for gases solution. Okay. So it said calculate number of moles. What do you do now? Our formula is concentration times volume. Now quickly check out something like I told you guys. What unit was given for volume? Quickly, the unit that was given for volume there, it was cm cube. So it means that we have to convert. We have cm cube here. We cannot use cm cube because our concentration is given in mole per dm cube. And now, like I told you, they're going to give you concentration. And they already gave you as 0.025 mole per dm cube. I told you guys that concentration is in mole per dm cube in these questions. Now, quickly, our formula is we have to first convert this guy to dm cube. We're going to divide by 1000. Just cancel out everything. 2 divided by 10, you sure you know that's going to give you 0.2. So 0.2 dm cube. Now from there, we're going to now get our answer as just multiply both of them. 0.2 times 0.025, which gives you answer 0.05. Hope you get. So it's very, very easy actually. You can see now from there, we've gotten our number almost straight up. Let's go to the next one. We don't have time. 16 dm cube of hydrogen gas at STP. 16 dm cube of H2 at STP. Now, what do you do here? What do we do here? We have dm cube of hydrogen at STP. So quickly look at dm cube. Means they're giving you volume. Whenever I see dm cube, cm cube, you know it's volume. So it means that they are telling us about number 3, the third formula there, because volume was given, and you should look for number of moles. So what do you do? And I think I forgot to say this. They were going to tell you at STP. Calculate number of moles of wisdom at STP. What they're trying to tell you is that calculate number of moles using the molar volume. This molar volume is at STP. I think I said it. Yes, I said it. Yes, I remember. So it means that we are going to be using molar volume. They only expect you to know this thing, 22.4. They may not give you, to be sincere. They expect you to know that molar volume at STP is 22.4. So what do you do now? Straight up, we're going to just use your formula. N equals to, what is volume? 16 dm cube. They already gave you in dm cube, so don't need to convert anything. 16 divided by 22.4. 16 divided by 22.4 is going to give you what? Your put your calculator. You're going to get 0.71 moles. So it means that your answer is 0.71. And you see, it's not taking our time at all. Once you can master these formulas, you can solve all the questions actually. So now quickly, number 5, we have 250 cm cube, 250 cm cube of an ideal gas. Exert a pressure of 72 millimeter of mercury, that's pressure, at 37 degrees Celsius. Now calculate number of moles. Quickly, you already know that you're going to be using this first formula. So number of moles equals to PV over RT. Now, what is volume here? Or what? Let's start from pressure. Pressure is 72 millimeters of mercury. If you didn't listen to the first part of this video well, I said something that pressure is in atmosphere. So you'll be able to use 0.082 pressure is in atmosphere as arrow. But now we're having millimeter of mercury. What do you do? So you have to convert millimeter of mercury to atmosphere. Now, how do you convert millimeter of mercury to atmosphere? You have to first know what is the relationship between them. And what is the relationship? 1 atmosphere equals to 760 millimeter of mercury, which equal to 760 torr. T-O-R-R. So you must take note. Millimeter of mercury equals to torr. It means that if 1 atmosphere equals to 760 millimeter of mercury, it means that 1 atmosphere is also equal to 760 torr. Now, 1 atmosphere is equal to 1.0, not 1.01 bar. Now, take note that 1 bar equal to 10 raised to power 5 Newton meters per square, or Pascal 5. So that tells you 2 things from what I've written. That torr equal to millimeters of mercury, then Newton meter square equals to Pascal. So you can see they are related, because you are seeing 10 to the power 5, 10 to the power 5, not minus. 10 to the power 5, 10 to the power 5. Then you are seeing 760, 760. So it means that they are related. Now, if you want to now relate atmosphere and Newton meters, what do you now do? Since 1 atmosphere equals to 1.01 and 1 bar equals to 10 times 10 raised to the power 5, so it means that 1 atmosphere, now let me just use this different color. 1 atmosphere equals to 1.01 times 10 raised to the power 5. Remember that 1 atmosphere equals to 1.01 bar, but this guy now 1 bar equals to 10 raised to the power 5. So once we now convert to Newton meters, we going to have times 10 raised to the power Newton meters square or Pascal. So this is the relation between atmosphere and Newton meters square or Pascal. So I'm going to show you the relationship between all of them. Now what do I do? Since 1 atmosphere equals to 760, so I have to now convert it. I'm going to use the relationship. So you must know how to use the relationship method for a JAMB exam. 1 atmosphere equals to 760 millimeter of mercury. Now we're looking for X atmosphere. We don't know the answer yet. So let's call it X, equals to 720 millimeters. We want to convert 720 millimeter of mercury to atmosphere. So why I put X here. We're doing that 1 atmosphere equals to 760. So it's a relationship method. What do you now? I'm going to cross it. So I'm going to multiply 1 times 720, 760 times X. This is how you do relationship method. If you have known values and you're looking for an unknown, just relate them. So from there now, if I relate them, I'm going to have 1 times 720 equal to x times 760. X times 760. So from there now, x equals to 720 divided by 760. I'm going to get your answer. And it's equal to 0.947 atmosphere. So this is our answer in atmosphere. Now we are left with something also. We need to find volume. And I told you guys that you cannot use volume in cm cube in solving this kind of questions. You have to convert it to dm cube. What do I do now? I'm going to divide by 1000. 250 divided by 1000 gives me what? Surely going to give me 0.25. Now, how do I convert? Where is my degree in Celsius? No. If you are good with chemistry, you're going to know that even physics, you have to convert the Celsius to Kelvin at all times. Remember that our formula for okay, I've cleaned that part. But our what's it called now? Gas constant. Let me write it out again. 0.082 atmosphere. Then we have dm cube. So it means that all the different things here must have this unit. Atmosphere, pressure. We have converted pressure to atmosphere. Volume now, it must be in dm cube. So this one is dm cube now. Then we have what's the next one? Moles. Is it moles? Sorry. Yes, moles. They told us in the question that it's probably surely no, we're looking for moles. Okay, yeah, we're looking for moles. Then that's the unit for number of moles. Then the next one there is temperature, and it is in Kelvin. So according to our question, temperature is in Kelvin. Hope you get. So from there now, it means we have to convert this guy to Kelvin. So what do you do now? You're going to add 273. To convert Celsius to Kelvin, you add 273. Please take note. You're going to add 273 to this guy. So if you add 273, you're going to be getting obviously 300 Kelvin. So from there now, if you put everything into this formula, you're going to do 0.947 times, what was the volume? The volume is let me wipe this thing off. We have volume, but temperature is 300. So volume now, you have 0.25. Then R is 0.082 times temperature is 300. So you're going to get 9.63 times 10 to the power n equals to 9.63 times 10 raised to the power minus 3 moles. That's going to be your answer. And oh, this is 37 not 27. So you must be very careful actually. I'm just in a hurry. I want to just solve these things very fast. So 37 plus 273 is going to give you it's 310, not 300. So if you change this to 310, let's quickly just do it with 310. It's going to give you, where is it? It's going to give you, so it's going to give you 9.3 and not 9.63. So it's 9.3 times 10 to the power minus 3. So you always add it up well. So 273 plus 237, so it's 310. So our answer to this question now, the fifth question, is 9.3 times 10 to the power minus 3 moles. Now we have two questions left. Let's quickly run them. So number 6 and number 7, remember it were 32 grams. Let me just write it here. 32 grams of oxygen atom and 32 grams of oxygen molecule. So now the first thing we must first know, the first distinction is that oxygen atom is just O, then oxygen molecule is O2. I think I was explaining in the last video. So as a molecule, it exists as O2, then as an atom, it exists as just O, because we have just one atom. So this guy is made up of two atoms to give us the molecule. Now, 32 grams of oxygen atom. How do you look for the number of moles here? Remember I told you guys that once you just see gram, the first thing that comes to your head is mass. So in the first formula there, n equals to mass over molar mass. So from there now you have n equals to, I hope you are adjusting this thing though, because very, very important for your exam. So you have 32 divided by now. The reason why I brought out this question that students usually make the mistake, they usually make this error. They told you oxygen atom. Don't go and use For instance, now the relative atomic mass of oxygen normally is, where is it? 8 and 16. So from there now, normally 16 for atom. Then for molecule, it is still the relative atomic mass of oxygen is 16. But since it's a molecule, we have to do 2 times 16. The reason I brought out this question is that you may be in a hurry and just quickly just do oxygen. Forget that it's O2. Please. You can say phosphorus atom now. Phosphorus atom is P4. So you have to do phosphorus is not 15 and 31. So you have to do 31 times 4. Learn these things, please. Don't be in a hurry. So for instance now, it means that for the second guy now, I'm going to have n equals to 32 divided by 32. Or you have to multiply 2 times 16. So for the first one now, the number of moles of oxygen atom is 32 divided by 16 is 2 mole. But for the second one, it is 1 mole. So you see, we got different answers. So if you're in a hurry now, they gave you any of the question, interchange them. You have failed it because we are getting 2 different answers here. 32 divided by 16 gives you 2. 32 divided by 2 gives you 1. And you get your answer. So I've been able to exploit the different formulas for calculating number of moles. But I want to quickly say something, because as a JAMBite, you must understand concepts. You must understand concepts. I want to tell you the difference between atoms, elements, compounds, and all those stuff. Because I think I should just do it in this video. This is related to what I'm doing. Before we start solving, we're going to solve JAMB questions. I want to solve JAMB questions now. Like I think it's about 20 questions. We're going to solve in real JAMB questions. So please take note of these formulas first. Then what I'm about to do now, the difference between atoms, elements, and all of them. So let's quickly explore them. The video is still very, very long, and you have to bear with me. You have to just do this thing on this video and forget about number of moles and everything. I want you to understand chemistry better. Like I told you, at the end of this series, you need to improve in your calculations very well. Solve any kind of questions on stoichiometry and all that, because this video is tailor-made to help you understand chemistry better and do better calculations. So it's not just even about just solving stoichiometric questions. Every other calculation you're going to get, calculation question you're going to encounter in your journey in chemistry, you'll be able to solve them. Hope you get. First thing is that I think it's shown on the screen that an atom is a single fundamental particle. So the difference between an atom and an element is that an atom is a single fundamental particle. So you just have oxygen atom. I'm actually doing distinction because of that oxygen and molecule stuff. Oxygen molecule and atoms rather. So an atom. So people make the decision and say that atoms and elements are the same. They're not actually the same. So the difference between them is that atom is just a single fundamental particle, while an element is a substance consisting of atoms with the same number of protons. So element is a substance consisting of atoms. So an element contains atoms, and they have the same number of protons. All these atoms have the same number of protons. Now, atoms are made up of subatomic particles like protons, neutrons, electrons, while elements consist of identical atoms. So what I'm trying to say in essence is that elements are made up of atoms, like different atoms. But atoms are made up of subatomic particles like protons, neutrons, electrons. So this tells you that an element contains atoms which contains protons, neutrons, and electrons. So element is like the bigger one. I don't know if you get the concept. So although if you can say hydrogen atom, we are still correct. If we say hydrogen element, we are still correct. Hydrogen is an element, but that element now contains hydrogen atoms. So although we're going to represent it as HH. So if they say what is hydrogen atom, write it in symbols. It's going to be H. Hydrogen atom is element, right? The element hydrogen is still H because element is made up of atoms. Hope you get. Then atoms are the constituent tiny building blocks, whereas elements are the bulk material. See, atoms make up elements. Then there are 188 known elements, while atoms are the individual particles of these elements. So there are currently 188 known elements in the periodic table, the modern periodic table, and we have the atoms that make them up are and they are made up of individual atoms. Hope you get it. Now, a single gold atom is an atom, AU. A bar of pure gold is an element. Now, if you have a bar of gold, of pure gold, that's an element. That's the entire bulk material. But the constituent, a single gold atom inside that constituent is an atom. So we have constituent inside the bulk material. That's what this thing is just trying to tell you. So finally, atoms are the building block of elements, while atoms are the building block of elements. An atom is the smallest unit of an element that retains that element's chemical properties. I think this is the definition in many of the O-level textbooks, that an atom is the smallest particular unit of an element that retains that element's chemical properties. While elements are defined by the type of atom they contain. So the type of atoms that an element contains are defined. So if we have chlorine element, it's because it contains chlorine atoms. Hope you get. So atoms are the building blocks of elements. So in case you are asked, dash are the building blocks of elements. Atoms, molecules. The answer is surely atoms. And you're good to go. These are things you should know. Then compounds versus molecules. A molecule is formed when two or more atoms bond chemically, while a compound is a molecule that contains at least two different elements. You have to listen very well at this point, because people make they make error and say molecules and compounds are the same thing. No, it's not true. Molecules and compounds are not same. Why? Because a molecule is formed when two or more atoms bond chemically, while a compound is a molecule that contains at least two different elements. But not all molecules are compounds. So therefore, all molecules, compounds are molecules, but not all molecules are compounds. Why? Because a molecule is formed when two atoms bond. So anywhere you just have two atoms bonding together, they are called molecules. So I have A plus B now, and they form AB. So that's a molecule. But if I still have A and A plus A, which gives you A2, A squared, that's 2A, A2. Now I'm going to write it as a subscript, H2, A2. So A2 now is a molecule because it consists of two different atoms. Understand? Two or more atoms make up a molecule. But if I have A2 now, that's not a compound. Why? Because the definition for a compound states that it must have two different atoms coming together. But a molecule does not restrict it to the two different atoms. One single element atom can come together and form a molecule. So can I have AA, which gives you A2, BB gives you B2, but I cannot have A2 now and say it's a compound. I can only have AB, A plus B, to give you a compound. Why? Because I will have two different atoms to give me a compound. Then molecules can consist of the same or different elements, while compounds must have different type of atoms. That's what I'll be trying to explain. For instance, now let's use an example. NaCl is a compound. H2SO4 is a compound. Why? Because we have different atoms in these compounds. But for molecules now, I cannot say that H2 is a compound. H2, because I just have two atoms of hydrogen combined to form hydrogen molecule. I cannot say O2 now is a compound. I cannot say P4 is a compound. They are just molecules. Why? Because they contain two different atoms. But I can still say that NaCl is a molecule because it contains two different atoms. I can say H2SO4 is a molecule. This fact is a compound too because it contains three different atoms. So the distinction is that molecules can contain the same atoms or different atoms, but compounds must only contain different atoms. So that's the distinction between them. So in some way, if the substance is made up of different type of atoms, it is both a molecule and a compound. But if it is made up of only one type of atom, it is a molecule but not a compound. So please take note of the distinction between all this stuff. Now, I want to also show you something, that relative atomic mass is for atoms. You know what I'm talking about, relative atomic mass? I'm saying that the relative atomic mass of carbon is for atoms. The relative molecular mass is for covalent compounds or molecules. For instance, H2O, oxygen, so covalent compounds or molecules. So, what is covalent compound or molecules? These are compounds and molecules that are made up of covalent bond. What is covalent bond? A covalent bond is formed between a metal and a non-metal. So that is covalent compound or covalent molecule. Now, but relative molar mass is between ionic compound. Please take note of these things. Relative molar mass is between ionic compounds. So in your JAMB exam or your exam, STOICHOMETRY, whatsoever, they can ask you NaCl. In chemistry, NaCl is dash. Sorry, in chemistry, the mass of NaCl is properly represented as dash. A, relative atomic mass. B, relative molecular mass. C, relative formular mass. Your answer is relative formular mass and not relative molecular mass. Why? Why? Because relative formular mass is for ionic compounds. Relative molecular mass is for covalent compounds or molecules. But we usually make the mistake, even textbooks, they will say that what is the relative molecular mass of NaCl? But it's wrong. Technically, in chemistry, we call it relative formular mass. So anything that involves ionic compound is formular mass. Hope you get. But if you take note of something, that in actual sense, formular mass can actually represent both ionic covalent compounds and molecules. Yes, it can actually represent all of them. So it's like a general term. It's a general term for all of them. These are things that many persons don't know. It's a general term for all of them. So it's a general term for all of them. But if they say covalent compounds, can just call them relative molecular mass. But if you are talking about ionic compounds, it can only be formular mass. So formular mass can represent both covalent, ionic, and all of them. So please take note of it. At relative atomic mass, relative molecular mass, relative formular mass are all ratios. That's why they are called relative. They are ratios. And they are the ratio of what? The ratio of the particular atom or molecule or compound to carbon-12. They are in terms of carbon-12. Previously, we usually use hydrogen. Now, they can ask you a concept question and say that relative atomic mass, relative molecular mass, they were previously in ancient times, they were represented in terms of dash. It's not carbon-12. It's in terms of hydrogen. But in current times, in the modern chemistry, it is represented in terms of carbon-12. Please take note. It is represented in terms of carbon-12. So the reason why it's called relative atomic mass, because I'm going to show you something now, that there's something called atomic mass. There's a difference between relative atomic mass and atomic mass. You must know how to use terms in chemistry. They may just try to test your understanding, especially for STOICHOMETRY, exams like STOICHOMETRY and typical science exams that test understanding. You must know the difference between all these things. So relative atomic mass is a ratio. It's a ratio. It's just a ratio. It does not have a unit. That's why I brought this thing up. It does not have a unit. They don't have a unit. They are just ratios. But they are represented in carbon-12. Why do I say they are just ratios? Because the definition of relative atomic mass now is that, for instance, let's use oxygen as an example. We're going to say that the relative atomic mass of oxygen is the average mass of one atom of oxygen divided by 1/12 mass of one atom of carbon-12. Why do we say 1/12 mass of one atom of carbon-12? The reason being that since we have carbon-12, it means that the relative atomic mass of carbon is 12 for carbon-12. Carbon can actually exhibit carbon-12 and carbon-14 as an isotope. So, but we are using carbon-12. You must specify and look at your options very well. You may go and put carbon-14, it's wrong, and you now put none of the above. You must take note that it's carbon-12 and not just anyhow carbon. So it's carbon-12 and not just carbon or carbon-14. So it's carbon-12. So 1/12 atoms. So if you say 1/12 times 12, you're going to get 1. So we said average mass of one atom of oxygen divided by 1/12 mass of one atom of carbon-12. So we're still getting the atomic number as 1, even though it's carbon-12, because of 1/12 mass of one atom of carbon-12. That was the reason in previous times they used hydrogen. Why? Because hydrogen has an atomic number of 1. Yes, they used hydrogen in previous times. Because we just said that, okay, average mass of one atom of oxygen divided by one atom of hydrogen. Why? Because atomic number of hydrogen is 1. But now we have changed it to oxygen. Carbon 12. So the unit is now in terms, relative atomic mass is now in terms of carbon 12 and not hydrogen. So please take note, it's now in terms of carbon 12 and not hydrogen. So you're going to see that there's something that in real sense, the relative atomic mass of of um of the different atoms, different elements in the periodic table, they are not actually whole numbers. It's because of this carbon 12. Because of this carbon 12. The reason is that the reason I actually use carbon 12 is because we want to balance for isotopy. Now, this brings us to isotopy. Isotopy is the reason why we don't have whole numbers relative atomic mass. There's a question like that. There's a popular question that will say, why do elements not have whole numbers as relative atomic mass? It's because of isotopy. So it's because of carbon exhibits two isotopes. We have carbon 12 and carbon 13. Oh, I was saying carbon 14. No, it's not carbon 13. So it's not carbon 14. It can exhibit carbon 12 and carbon 13. So this is the reason why modern chemists now adopted carbon 12 to be the standard, to be the defining standard, because it has a basic mass of 12 units. So it's now the defining standard, and that's why we now have relative atomic mass to not be in whole number. So for instance, now the relative atomic mass of oxygen is not really 16, it's 15.999. 15.999. Relative atomic mass of, for instance, now sodium, I don't think it's 23. It's going to be 22.8 something, 89 or 989, something like that. So you see, they are not whole numbers. Hydrogen now is not just 1, it's 1.008. So these are things that are part of this carbon 12, and just to balance for isotopes, because actually most elements don't exhibit in one state, they exhibit in different states. That's what isotopy means. You know that isotopy is the ability of um, an element to exhibit in different forms, because it has different number of neutrons. Hope you get. Now, with that being said, I think I'll be able to do justice to that relative atomic mass is a ratio, and it's expressed in terms of carbon 12. That's the average mass of one atom of that element you're looking for, divided by 1 over 12. Taking of 1 over 12. So in case they cannot ask you a concept question. This time now, no calculation. Just say what is the division of relative atomic mass or relative molecular mass. If it's molecular mass now, it's going to be one atom of the molecule of, maybe for instance now, hydrogen molecule divided by 1 over 12 mass of one molecule, because this we're talking about molecule. Molecular mass is for molecules, atomic mass is for atoms, while formula mass is for ionic compounds. So one atom of carbon, one molecule of carbon 12, we're talking about molecule. Hope you get to 1 over 12 mass of one atom of carbon 12, or one molecule of carbon 12 of one form is that is the defining factor for relative atomic mass, relative molecular mass. So please take note, in case you are asked, it's in terms of carbon 12 and not hydrogen. But they actually, in ancient times, in previously, chemists used hydrogen, but now we use carbon 12. Hope you get. Then, like I was trying to tell you, there's also something called atomic mass. Now, atomic mass is um atomic mass is in terms of atomic mass unit. Some people call it AMU or U. Can represent that AMU or U, atomic mass unit. The atomic mass unit is equals to that Daltons. One atomic mass unit equals to Daltons, 1 Dalton. So you can say what's the unit of atomic mass? Is either atomic mass unit or Dalton. Remember that relative atomic mass don't have units because they are ratios. So the unit is going to cancel out. So they don't have units, they are ratios. So please take note. So the atomic mass is in terms of AMU or Daltons. Then molecular mass is also in terms of AMU or Daltons. Also formula mass or formula weight is in terms of AMU or Daltons. So please take note of these things. And the vital one now, we have said three different things. Now when you have something relative atomic mass, relative molecular mass, relative formular mass, they don't have units. Then atomic mass now, they have units. They are represented in terms of atomic mass units or Daltons. So they say what is the atomic mass of carbon now? The atomic mass of carbon is going to be the relative atomic mass is 12. So since relative atomic mass is 12 without unit, so it means that the atomic mass is going to be 12 atomic mass units, AMU, or just U, or 12 Daltons, because atomic mass unit equals to Daltons. Hope you get. Then lastly, molar mass is represent all of them. Molar mass represent all of them. So molar mass represent all of them. So it comprises of atoms, compound, molecules. So it is the only one that has units of gram per mole. So people make the mistake and say that relative atomic mass, just put no. Relative atomic mass does not have units. If you see that, once they give you, look at your JAMB pack or your YX questions, post-it, always like they give you the formula, the relative atomic mass of elements in bracket. They don't add units to it. Why? Because they don't have units. Molar mass have units. That's why when we are calculating molar mass from number of moles equals to mass over molar mass, we know that molar mass equals to gram per mole. So that's the unit for molar mass, gram per mole. And it encompasses atoms, compound. So molar mass is the mass of 1 mole of a substance. So molar mass is the mass of 1 mole of a compound. So it encompasses all of them. So I can say, look for the molar mass of hydrogen atom. And I'm correct, because I can use it to represent atom. But I cannot say look for the relative molecular mass of hydrogen atom, because relative molecular mass just involves molecules, or molecular mass just involves molecules. Or I cannot say look for the relative molecular mass of sodium chloride. Also, people make the mistake, but in actual sense, it's actually supposed to be relative formula mass or formula mass, because hydrogen chloride is an ionic compound. But I can say look for the molar mass of hydrogen chloride. I'm correct, because molar mass can encompass all of them. But formula mass, atomic mass, molecular mass, or if you add a relative, if they're the ones that involve ratio, they don't encompass that at all. Hope you get. So they don't have unit at all. And molar mass encompasses all of them. So those guys now, they involve atomic mass involve atoms, molecular mass involves molecules or covalent compounds, while formula mass involves ionic compounds. Hope you are able to get the distinction between all of them. Now, let's look at the numerical value. Okay, so that observation shows us something, that they have the same numerical value. So take for instance, we have, let's write the relative molecular mass. Let's use H2O, for instance, is a molecule and a covalent compound. So H2O now, it means that the relative molecular mass of H2O is 18. You know that H is 2 times 1 plus 16. So that gives you 18. Then it does not have units. So then we have our mass as 18 mole. Then we have our molar mass as 18 gram per mole. So you see now, they all have the same numerical value of 18. So if you calculate the individual composition here, add up the relative atomic mass, you're going to get 18. So they all have 18, 18. The only difference is that this guy does not have units. This guy has units as AMU or Daltons. The symbol for Daltons is D, DA rather, and U. So AMU can be presented as U for short, or you have Daltons. So either 18 AMU, 18 Daltons, or 18 U. So then molar mass 18 gram per mole. So this is the distinction between these three guys. And in case you're asked in your exam, probably a complicated exam like A level exams, UPEP, maybe JAMB may not go that far. You may be tested something like this. So you must know the difference between this stuff. If you really want to aim for perfect scores, you know, some persons aim for perfect scores, want to get 99, 100. This you must understand things like this, because this is what differentiates you from other students that are just aiming for maybe 80, 90 you get. So now 18 nano and 18 gram per mole. Let's quickly move to the last section of this video where we're going to be solving questions. This is practical JAMB and wire questions on the mole concept. So there are a lot of questions. So just make sure you get your writing materials, and if you need to take a bottle of water, take a bottle of water if you are exhausted, because we're going to be solving questions now. And if you're enjoying the video, let me know in the comment section. I am enjoying the video, I like the video. Just say something in the comments. Let others know that this video is worth watching, that they need to watch it. They just need to watch it. They want to do very well in their exam. So before we run, I want to show you something on ammo. Although I'm going to solve a similar question to that. So the question should be shown on your screen. An electron has a mass of 9.1 times 10 raised to the power 28 grams. Then say calculate the mass in atomic mass units. First thing you need to take note of is that one atomic mass unit equal to 1.66 times 10 raised to the power minus 24 gram. That's the first thing to take note of for this question, because if you see the kind of question in your exam, if you don't know this, you have failed the question. And some exams may not place it. Maybe people should tell me they may not give you the unit. So it equals to 1.66 times 10 to the power minus 24 grams. Then what are we are able to look for atomic mass units in. So if you look for the mass of the electron in atomic mass units. Now, since we know this relationship, and I taught you guys earlier on that there's a relationship called the principle I use called the relationship method. Since I have 2 grams, I can look for atomic mass unit easily by just relationship. Now, let me call this what we are looking for X ammo. Then I have 9.1 times 10 raised to the power minus 28 grams. So what do I do? I'm going to relate them. Just draw a cross. Then I'm going to multiply them. So I'm going to have 1 times 9.1 times 10 raised to the power minus 28 equal to x times 1.66 times 10 raised to the power minus 24. So from there now, I'll now look for x. How do I get x? I'm going to say x equal to 9.1 times 10 raised to the power minus 28 divided by 1.66 times 10 raised to the power minus 24. Now, x equals to 9.1 divided by 1.66 give you 5.5. Then times 10 raised to the power. Now, minus 28. According to indices, when you have division, it changes to subtraction. So you're going to introduce minus. Then you still have, we're going to open your bracket and put your 24. So I have minus 28 minus 24. And according to mathematics, when you have minus minus, it gives you plus. When you have minus plus, it gives you minus. When you have plus minus, it gives you minus. Then when you have plus plus, it gives you plus. So since I have minus minus, it gives me plus. So what do I do? Minus 28 plus 24. Now 28 is greater than 24, so I'm going to have minus 28 plus 24, which gives me minus 4. So when you have questions like this, best to leave them in index form. Why? If you start pressing 0.0000 in your calculator, your examination calculator, you're going to have issues. Say you are doing CBT and you're not allowed to use calculator. So you have to just leave them in index form. So you're going to just leave these guys, resolve them together, then you resolve these other parts together. So like I've done 5.5 times 10 raised to the power. So when I've simplified it here now, I can now add my minus 4. So I just have to just leave it in index form, simplify it through that method. When you have division, you're going to change to minus. Then when you have multiplication, it changes to plus. That's what you just need to know for indices. So that's the way this question is going to be resolved. And that gives us our answer as 5.55 times 10 raised to the power minus 4 atomic mass unit. So this is how to convert from grams to atomic mass units. It's too long and I have to cut it at this point on this YouTube channel. So to watch the continuation of this video, I'm going to be dropping the link of the YouTube channel on the description of this video or the first comment section. or you can just search for unusual science tutorial. That's where the full chemistry video is going to be uploaded. Reason being that this channel is actually for physics videos. I just decided to upload it here for those that may not know about that YouTube channel. So just go there and search for unusual science tutorial. You're going to see the full video, chemistry video there. And subsequent chemistry video on the stoichiometry series and probably other videos will be dropped there. So just go there, subscribe to the channel, recommend it to your friends, and like the video and all that. So that's going to be all for this video. We still have much more videos to drop on physics, chemistry, and all that. So just stay tuned and stay glued. And don't forget, as usual, to keep reading till you become the book. I remain the phenomenal Dr. Jeremiah, and I will see you in the next video.